Hello dear students, welcome back to EZEE Notes. Today we will start our chapter number 4, that is refraction of light on plane surfaces. Okay, so today is the day of part A, in which we will be studying refraction, laws of refraction and about refractive index. These three topics we will be studying in this part. So what is refraction? What do you mean by refraction? Basically, refraction means bending of the path of light. See, the light will be moving in a single direction. As soon as the medium changes, light will change its path. That is nothing but refraction. That process is known as refraction. The change in direction of path of light when it passes from one transparent medium to another transparent medium is called refraction. The refraction of light is essentially a surface phenomenon. Just a minute. Refraction of light will be a surface phenomenon. It will happen on the surface. See, okay, it has been observed that when a ray of light travels from rarer to denser medium, let us see. We have two mediums. This is a boundary. Okay, this is upper medium. Let us consider as rarer, and lower will be denser. Okay, rarer means which have low optical density. Denser means which will have higher optical density. Like as we compare to glass and air, glass will have higher optical density and air will have lower optical density. If we compare glass and water, so glass will have higher optical density but water will have lower optical density, in that way. Like if we compare glass and diamond, diamond is having higher optical density while glass is having lower optical density. Anyone can be rarer or denser by comparing any two of the mediums. So let us consider the upper one is rarer, the lower one is denser. Okay, so there will be a ray called incident ray which will fall on the surface on the boundary. So this is what, this is normal. A perpendicular line passing through the boundary is known as normal. Normal makes an angle of I with the incident ray, known as incident angle. Okay, now what happens when the ray of light travels from rarer to denser medium? When it travels from rarer to denser medium, it bends towards normal. It bends towards normal. See, instead of going in this way, it will bend towards normal like this way. This will be the actual way of refracted ray. So this is the refracted angle, and this is what angle of deviation, by how much angle it is deviated. The actual ray, it was the actual path, the ray was deviated by some angle is known as delta. Delta is deviated angle. See, when the ray of light passes travel from rarer to denser medium, the ray bent towards normal. That is, angle R will be less than angle I. See, angle R is less than angle I. The deviation of the ray from its initial path is delta is equal to I minus R. We can say mod of I minus R. Why I am using mod here? Mod means difference between I and R. Okay. See, if we are going from rarer to denser medium, we can say I is greater and R is lesser. But same thing, if we travel from denser to rarer, at that time what happens? This is the boundary. From denser to rarer, if it travels, this is normal, right? This is incident ray, this is angle of incidence. This was the actual path. It will go in this path. Sorry. Denser to rarer, right? It will go in this path, away from the normal. It will go, this is R completely. And from here to here is delta. So here I can say delta is nothing but R minus I. Here it was I minus R, here it will be R minus I. Simply we can remember the deviation is nothing but the difference of angle of incidence and angle of refraction, difference between them. Either one of them can be greater. Okay. So when the ray of light travels from denser medium to rarer medium, the ray bend away from the normal, that is R is greater than angle I. The deviation of the ray from its initial path is delta is equal to R minus I. So how you can remember? Simple. Denser to rarer, it means dur. Dur means away from normal. Remember the other one will be, however it can be remembered, right? If you remember one, the other one will be easier. Simple. Next, when a ray of light incident normally on the surface. Normally in the surface means, see here, this is normal, right? This was normal. This is normal. So if the ray of light comes in this way only, incident on normal, that is nothing but angle I will be 0 degrees. Angle I will be 0. It does not make any angle with normal. So it will pass undeviated. It will pass undeviated. So angle R will also become 0. Okay. So separating two medium passes undeviated, that is delta I is equal to 0 and delta R will also be equal to 0, and the deviation of the ray is 0. There is no deviation because it passes undeviated. Next thing, causes of refraction. What are the causes of refraction? Why does refraction occurs? When the light travels from one medium to another medium, its speed changes. What happens? Its speed changes. Because of this change in speed, the direction of light also changes. Okay, due to change in speed, the direction also changes. Next, if the light slows down, if the speed decreases, it bends towards normal. If the speed increases, it bends away from the normal. It means that in denser medium, speed increases. Sorry. Speed decreases. In rarer medium, speed increases. See, if light slows down, bend towards normal. When does it bend towards normal? When it goes from rarer to denser means towards normal. Towards normal means in denser, its speed decreases. In rarer, its speed increases. If the speed of light does not change, it does not bend and goes straight. If the speed does not change, it will go straight. Simple. Note point. You need to remember, when the light falls normally, that is angle of incidence is 0, its speed changes, but its direction does not change. In this, speed will change because mediums are changing, speed will change, but direction won't change because of it passes undeviated. Simple. Okay. Next, laws of refraction. You need to remember we have two laws which was given by a scientist known as Wilbur Snell and also known as Snell's laws. Okay. Next, first law is the incident ray, the refracted ray and the normal at the point of incidence all lie in the same plane. See, whenever we draw any ray diagram, here incident ray, normal and refracted ray, all three are lying in the same plane. Same plane means on the same surface. Okay. Next is the sine angle, the ratio of sine angle of incidence to the sine angle of refraction is constant. Sine I upon sine R is constant. That constant is mu to 1. How we have to read? Mu to 1. What does it mean? It means that the constant is called refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. That's why we are reading it as mu to 1. Refractive index of second medium with respect to first medium. Okay. Next, what is refractive index? We'll see. The refractive index of a medium is defined as the ratio of speed of light in vacuum or air to the speed of light in that medium. What is refractive index? Mu is speed of light in air. It is denoted as C. It is right. Speed of light in air by speed of light in medium. So we can say it as C upon V. What is C? C is speed of light in air, which has a constant value, that is 3 into 10 to the power 8 meter per second upon V. C has a constant value, that is nothing but speed of light in vacuum or air is constant. It travels with a speed of 3 into 10 to the power 8 meter per second. Okay. So we can find mu, that is nothing but refractive index by C by V. Okay. Next, the refractive index of medium 2 with respect to medium 1, that is nothing but mu 2 upon mu 1 depends on the speed of light of two media. Let us see. For mu, what I can write? That is C by V. So C by V1 divided by, sorry, V2, right? Mu 2 upon mu 1 we are talking about. C by V2 upon C by V1. C is a constant, so C and C will get cancelled. Denominator become numerator, so it will be V1 upon V2. Mu2 by mu1 is equal to V1 upon V2. Since the speed of light in medium is V is equal to C by mu. So it is inversely proportional. V1 by V2 is mu2 by mu1. So if V increases, mu decreases. If V increases, mu decreases. See, mu2 by mu1 is V1 by V2. It is inversely proportional. Inversely proportional means if one increases, the other decreases. Next, in simple words, the refractive index compares how fast light travels in two different mediums. How fast the light can travel in two different mediums, it compares simply. Next, conditions for a light to pass undeviated. First condition was I should be 0, right? It should pass normally. The angle of incidence at the boundary of two medium is 0. Next, when the refractive index of medium 2 is same as that of medium 1, it is nothing but mu1 and mu2. If they are same, it can pass undeviated. See, like this. This is normal, right? So it can pass undeviated like this because both the mediums are same. The speed remains same. If the speed remains same, it will pass undeviated. Okay. Okay. Next thing. Factors affecting refractive index. What are the factors? There are three main factors. First one, nature of the medium. See, the lower the speed of light in medium, the higher is the refractive index. Nature. See, if you imagine where you can run easily, in air or in water. In air, right? In water, your speed decreases. It means that its refractive index is more. Simple. So refractive index depends on the medium as well, nature of the medium. Next is temperature of the medium. As soon as we increase the temperature, the refractive index decreases. Why does it decreases? See, what happens as soon as we increase the temperature, the molecules of the medium starts moving fast. Its speed increases. If the speed increases, the refractive index decreases. Okay. Next is color or wavelength of light. In air, all color travels at the same speed. In air, every color travels with same speed. That's why speed of light in air is constant, 3 into 10 to the power 8. But in medium, different color travels with different speed. Red light travels fastest, violet light travel slowest. So mu of violet will be more and mu of red will be less, right? Because V is inversely proportional to mu, which travels fast, has the least refractive index. So refractive index is maximum for violet and minimum for red light. Okay. Refractive index decreases as wavelength increases. So therefore, we can say that lambda is also inversely proportional to mu. As wavelength decreases, refractive index increases. Why does it happening like that? Let us see here. After this, okay. Principle of reversibility. What do you mean by principle of reversibility? According to the principle of reversibility, the path followed by a ray of light is reversible. It comes back to its in the same line. See, this is a boundary and this is normal. So if the ray of light passes like this, it can pass like this as well. This and this. It will go in this way and comes back in the same way. This is nothing but principle of reversibility. It comes back in the same direction. So if the ray of light travels from medium 1 to medium 2 and gets refracted at a boundary, then the same ray will follow the exact reverse path if it travel back to medium 2 to medium 1. If it is going from 1 to 2, it will follow one path. But if it's coming from 2 to 1, it will follow the same path as well. Okay, remember that. So when the light goes from medium 1 to medium 2, refractive index of medium 2 with respect to medium 1 is sin I is equal to mu 2 1. That is nothing but sin I upon sin R is equal to mu 2 by mu 1. You need to remember this. Sin I upon sin R is equal to mu 2 by mu 1. So when the light goes from medium 2 to 1, it will become this sin R upon sin I is equal to mu 1 upon mu 2. So if you multiply both of them, it will be 1. See, multiply. See here, it is mu 2, sorry, it's mu 2 by mu 1. Here it's mu 1 by mu 2. Both will cancel out each other and the answer remaining will be 1. So we can say that mu 2 1 is inverse of mu 1 2. or mu12 is inverse of mu21. They'll be inverse. For example, if refractive index of glass with respect to air is 3 by 2, refractive index of glass with respect to air is 3 by 2, inverse will be 2 by 3. Refractive index of air with respect to glass will be 2 by 3. Refractive index of glass with respect to air is 3 by 2. So the refractive index of air with respect to glass will be 2 by 3, inverse. Both of them will be inverse of each other. Okay. Next, effect of refractive index on speed, frequency and wavelength of light. See, we know that V is equal to F lambda. V is equal to F lambda, where V is speed, F is frequency and lambda is wavelength. So V lambda is equal to V by F. Remember that speed and wavelength depends on medium, but frequency depends on source. If the source of light changes, frequency changes. If the source does not change, frequency does not change. So when the light goes from rarer medium to denser medium, only medium is changing. So frequency remains constant. Speed decreases, so the wavelength also decreases. Rarer to denser. In denser, speed decreases. Wavelength also decreases. If follows the inverse, speed will increase and wavelength also increases, but frequency remains constant when it travels from denser to rarer medium. Okay. Next, relationship between the wavelength in two media. In simple way, I'll explain. Instead of going on this completely, we know that lambda is inversely proportional to mu, right? So we can say that lambda 1 upon lambda 2 is equal to mu 2 upon mu 1. Simple. It can be anything: air, glass, water, any two mediums, air and glass, air and water, water and glass, any two. Simply you can learn this, go through this, and finally you will get this only. Okay. Next one, refraction of light through a rectangular glass block. Let us consider a glass block. Okay, we'll take a 2D shape one day. There is a glass block. See here. Now we'll pass what? We'll pass the ray of light here. This is incident ray. This is what? Incident ray. I. Incident ray. Now what will be normal? This will be our normal. This is what? Normal. Okay. We'll change the color of it. This is incident ray and this is, so this will be angle of incidence. Now outer surface is air, inner surface is glass. So it is going from rarer to denser. It will bend towards normal or away from normal? It will bend towards normal. Why? While going from rarer to denser, towards normal. So we'll go towards normal. Okay, let us go towards normal like this. A bit like this, towards normal. Instead of this way, we'll go straight towards normal. So this is angle of refraction and this is the refracted ray. Okay. Now again, this will be our normal. Right. This is normal 1, so this will be normal 2. So this will also become, this is R1 and this will be R2. First refraction and second refracted ray angle. First refracted angle and second refracted angle. Now if it passes from denser to rarer, it will bend away from the normal. It will bend what? Away from the normal. Like this. Away from the normal. This is called E. And emergent ray is what? emergent ray. This is angle of emergence E. Now, what was the initial path? Initial path was this. This was the initial path, right? This was actual initial path, like this. See, straight line. This was the actual initial path, but the final path is this. So this distance is known as lateral displacement. Lateral displacement. See what happens when the ray of light passes through glass block. It goes refraction 2 times. It causes refraction how many times? 2 times. One on this surface, first surface, one on the second surface. While coming to the first surface, it is going from rarer to denser medium, so it will bend towards normal. And while going from second to third surface, it will bend away from normal because it's going from denser to rarer medium. And the ray gets deviated laterally. With its initial path. So this displacement is known as lateral displacement. Easy. Next, the lateral displacement x depends on thickness of the block, okay, the angle of incidence, refractive index, and wavelength of light used. In these 4 things, it will depend: thickness, angle of incidence, refractive index, and wavelength of light. Next, multiple images in a thick plain glass plate or a thick mirror. Okay. Let us take a thick plain glass mirror. Take this. Like this. Yeah. We can do it like this. We'll take this. No, this is good. Okay, let's take this. What's happening here? A ray of light falls here. Okay. Now what happens is it will get reflected back because there is a reflection as well, right? Because if it's a reflecting surface, it will reflect back because it's a mirror, thick mirror. Okay. Now if it reflects back, but it is also a glass mirror, a thick glass mirror, so it will also undergo refraction. See here, this will be the first image, image 1. Now rarer to denser, it will bend towards normal, right? Again it will go reflection, so this is the image 2. Again rarer to denser, it will bend towards normal, again like this. In this way there will be multiple images formed. Okay, multiple images will be forming here. We can see many images, but the brightest will be second image. Second image will be the brightest. You need to remember only this. Second image will be brightest, others all will be decreasing brightness, will be with decreasing brightness. Brightest will be second, third, fourth, and fifth will be like it will be going in the decreasing format of brightness. Brightness will be decreasing while we go from third, fourth, and fifth. Let us see some questions. The first one: a light ray does not bend at the boundary in passing from one medium to another medium if the angle of incidence is 0 degrees. We learned, right? For undeviated ray, it will be 0 degrees. Next, the highest refractive index is of diamond. Remember this: highest is of diamond, lowest is of air. Next, figure shows a ray of light as it travels from medium A to medium B, from here to here. This way it's going. Okay. Refractive index of A with respect to B, that is nothing but mu A by mu B we need. Okay. We know that sin I by sine r is equal to mu 2 by mu 1, that is nothing but mu b upon mu a. So we can inverse that. Mu a upon mu b is equal to sine r upon sine I. What is sine r? R is 45 degree and I is 60 degrees. So sine 45 degrees upon sine 60 degrees. What is sine 45? Sine 45 is 1 by root 2. 1 by root 2 and sine 60 is root 3 by 2. So mu a upon mu b can be written as 1 by root 2 into, this will become 2 by root 3 because it is in the denominator. So 2 by root 2 is root 2. Therefore we can write it as root 2 upon root 3. Root 2 upon root 3. Option B will be the right answer. Easy? Easy. Next. Two rays PQ and PRS are inserted on a rectangular glass block as shown in the diagram. Okay. Observe the diagram and answer the following questions. So let us observe the diagram. See, first and second, what they are asking, have greater lateral displacement on emerging out of the block. Which have the greater lateral displacement? See, which will bend more towards normal? It will have greater lateral displacement, right? See. See, the more it bends here, the more the ray will be here, right? So it will have more greater lateral displacement. So which is bending more, this or this? See, this is bending more. RS is bending more. So which will have greater lateral displacement? RS will have greater lateral displacement. Okay. Travel with greater speed in the block. If it's coming towards normal more, if it's coming towards normal, it will have less speed. It's not coming towards normal, right? It will have greater speed. Simple, right? When will it bend towards normal? When the speed slows down. So PQ will travel with greater speed. PQ. Scatter more in the atmosphere. Scatter more in the atmosphere. Which will travel slow. It might scatter more. Which will travel slow. It might scatter more. Answer will be RS. Slower the speed, more is the scattering. Okay. Next. Speed of blue light in water is more than green, more than orange, more than violet, more than red. You know this, right? Vibgyor. So they are asking about speed of light. As we move from violet to red, speed increases. Speed increases. They are asking about blue. Blue comes before green, yellow, and orange and red. More than green, no. More than orange, no. More than violet, yes. It comes after violet, right? So its speed will be more than red, no. Done. Next. When a ray of light travels normal to the given surface, then the angle of refraction is 0 degrees. Both angle of incidence and angle of refraction will be 0. Next. What is the relation between the refractive index of water with respect to air and refractive index of air with respect to water? So we can say that refractive index of water with respect to air is inverse of refractive index of air with respect to water. First one. The refractive index of water with respect to air is what? Refractive index of water with respect to air is what? They haven't given. It is 4 by 3. So calculate the refractive index of air with respect to water. So it will be inverse. So refractive index of air with respect to water we need, right? It will be 1 by refractive index of water with respect to air. That is nothing but 1 by 4 by 3. It will become 3 by 4. Okay? Inverse of that, simple. Next. A ray of light falls normally on a rectangular glass slab. Draw the ray diagram showing path of ray till it emerges out. It's going normally, so it will pass undeviated. Incident ray, refracted ray, and emergent ray. It will pass undeviated because it's going normally. Normally means perpendicular to the surface, along normal. Next. Refractive index of glass with respect to air is, it's 8 by 9. 8 by 9, yeah. Find the refractive index of water with respect to glass. Glass with respect to water is 8 by 9. Water with respect to glass will be 9 by 8, right? Simple. Inverse of that. Name the principle used to find the value in part A. Another principle of reversibility. Principle of reversibility. Okay. Next, if we change the temperature of water, then the ratio 8 by 9 remains same. Yes or no? When we change the temperature, refractive index decreases, like changes, right? If we increase the temperature, it decreases. If we decrease the temperature, it increases. So it does not remain same. No, it does not remain same. Okay, remember. Next, light travels a distance of 10x units in t1 time in vacuum, and it travels a distance x units in time t2 in a denser medium. Okay, using the information, answer the following question. Light covers a distance of 20x in time t1 in diamond. True or false? It's false. Why is it false? Because diamond is a denser medium, so speed will decrease. It's saying that 20x in t1, but speed is increasing. No, right? Speed won't increase, speed will decrease. Next, calculate the refractive index of the medium in terms of t1 and t2. Okay, so mu2 upon mu1 is equal to what? V1 upon V2. Now mu2 is mu, refractive index of medium. Mu1 is air, right? Vacuum they have written here. Mu1 is air, so we can, refractive index of air is 1, so we can let it go. Next, V1. What is V1? V1 is 10 distance by time, 10x by t1, and V2 is x by t2. X by t2. X gets cancelled, so it will become 10 t1 upon t2. 10 t2 by t1 is the refractive index of medium. Next, the diagram below shows two parallel rays A and B incident from air on air glass boundary. Okay, both are going. Copy and complete the paths of rays A and B. Let us complete the paths of A and B. Okay, A is orange and B is blue. So which will deviate more? Vibgyor. So orange will have more speed compared to blue. So if it has more speed, it does not bend easily towards normal. So blue will be like this, it will be like this, slightly. Okay. Next, how do the speeds of these rays differ in glass? Simple. Speed of orange will be greater than speed of blue. Vibgyor. Okay. Are the two refracted rays in glass parallel? No. Why they are not parallel? Because their speeds are different. They'll go in a different way. The diagram below shows that an observer sees the image of an object O at I. Instead of here, he is seeing the image here. Why? Because of lateral displacement. Right? Name and define the phenomena. Which phenomena here? Lateral displacement. Next, state the effect on X when Y increases, Y decreases. See, Y is thickness. If thickness increases, lateral displacement increases. X also increases. Lateral displacement. If thickness decreases, X also decreases. Okay, done. Easy. So this completes our part 1. So we will meet in the next part, that is part B. We'll learn about prism. So till then, keep supporting us and keep studying from us. Bye bye.